Hello, ladies and gentlemen. Today we're going to talk about area of regular polygons. Regular again means all sides are congruent, and polygons is a many-sided shape. So you're going to need your calculator, you're going to need something to write with, and you're also going to need the foldable. Okay, so to get started, let's talk about the parts that we're going to be referring to when we talk about regular polygons. Okay, so now again, regular means that all sides and all angles are congruent. So making sure that we remember that when we're talking about regular, that all sides and all angles are congruent. So what does it mean to be a side? Again, all the sides are at equal length, but the sides are going to be on the outside, the parts that make up the polygons. Okay, so that red bar there, what I would do in your notes, since you might not have colors, if you have colors, go ahead. I would draw and I would say that this is what we are going to refer to as a side. Okay, the next thing we need to write down is what a radius is. Now a radius is typically part of a circle. So if I were to draw a circle, again, I would draw a circle around the shape. How we're going to define a radius when we're talking about anything other than a circle is the distance from the center of the polygon to a vertex. And a vertex is just where the two sides are going to meet. So again, since you might not have color, if you have color, you can do it in color. But if you don't have color, I would draw an arrow to this and say, okay, yep, that's my radius. And lastly, a word that we might not be as familiar with is called the apothem. And the apothem is the distance from the center to a midpoint of a side. So that's going to be the blue arrow that pops up on your screen, or the blue line that pops up on your screen. This is what we call the apothem, okay? And now when we get to talking about this stuff, all of these are going to be very important when I try to find the area of these regular polygons. Every one the same is equally important. So apothem, radius, and side. Understanding what this means so that way when we go forward, when those words pop up, it's not new for us. So the first example we have today is to find the area of a regular pentagon with sides of 4 inches. So for starters, if I didn't have a picture, we'd have to understand that pentagon means 5 sides. Okay, so now I would maybe draw a pentagon out and I would label that all the sides equal 4 inches. And I know that all the sides equal 4 inches because of the word regular. Okay, so now that the sides all equal 4 inches, how do we go about maybe solving this? How am I going to figure this out? Well, for starters, the reason we introduced the words apothem and radius is because we're going to use those lengths to help us solve problems like this. So first thing I want you to do is draw in this triangle, okay? We know that this is going to be a 90-degree angle because I'm dropping that from the center right down to the side. So I have a 90-degree angle, but I don't quite know the other sides. The nice thing about this apothem then is it's splitting this side in half because it's going to the midpoint of my side. So then I would know, since it's splitting it in half, that this little side of my triangle is going to be 2 inches. Okay, well, that's cool, but how does that even help me? Well, we've spent some time talking about interior angle measurements. Okay, we've talked about how many degrees a 5-sided polygon has, how many degrees a 12-sided polygon has, and that's going to come back into play now when I'm trying to solve this regular pentagon. So, for starters, I'm going to go back and I'm going to figure out how many degrees are in this pentagon. So again, in order to find the degrees, we have to take n minus 2 times 180. And n in this instance is 5, so 5 minus 2, we have to multiply that by 180. And if I take 5 minus 2 times 180, so 3 times 180, I get back the number 540. So I know that I have 540 degrees in this entire pentagon. Okay, again, Ms. Kessler, why does that help me? What if I were to construct this triangle a couple more times? If I go all the way around my shape and I can construct all of these triangles. What do you notice? All of them should be equivalent, right? Because they're sharing the same sides, and the apothem is splitting it into 2 congruent sides. All my radius are going to be the same. So what do you notice? it looks to me like this triangle occurs 10 total times. Okay, well, cool, Miss Kessler, like that's great, but why does this help me? Well, if we see this angle right here is going to occur 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And I know that all of these, I'm going to circle them in orange because it's getting a little crowded. All of these angles on the inside of my pentagon have to be the same. So I can know exactly what one is. I'm going to take that 540 and I'm going to divide it by 5, number of sides. So 540 divided by 5 gives me 108 degrees. So now all of these orange circles, the angles inside them have to be 108 degrees. But those angles seem to be divided in half. So if they're divided in half, that means I'm going to take this one away and I'm going to divide by 2 again. And I'm going to get the number 54. So when I take one away and I divide it by 2, I get 54. So long story short, what we want to do once we figure out the degrees, we want to take the degrees, total degrees, and we want to multiply, or we want to divide it by 2 times n. So since I had n sides, I had 5 sides, but I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different angles. So that would be 2 times 5. I'm doubling the amount of sides I have. I'm doubling the amount of angles because I'm cutting every angle in half. So now if I cut that in half, okay, again, I'm dividing my total degrees. I'm taking 540 and I'm dividing it by 10. And that's going to give me this little angle in here. Now I'm going to redraw this triangle for us because it's a little crowded in my shape. So if I redraw this triangle, now I know that this is 2 and this angle right here is 54 degrees. So we know how to find the area of a triangle. Since I've created 10 triangles, why don't I just find the area of the triangle and then multiply it by 10 because there's 10 triangles. So if I were to want to find the area of this triangle, in order to find the area of a triangle, I need the base and the height so I can divide it by 2. But right now I'm missing that height value. So how can I use some prior knowledge to help me figure out that height value? It looks like I have an angle and I have 2 sides. Now that angle isn't 30, it's not 60, and it's not 45, so I'm not going to use special right. So I hope it's ringing in your head that we need to use trig. So if this was my reference angle, it looks like I have the opposite side and I have the adjacent side, so I'm going to use tangent. Tangent of 54 equals x over 2. Again, if this is confusing you, make sure you check back to your tangent or your trig notes. Now, how do I solve this? In order to get rid of division by 2, I multiply both sides by 2, so I can get those 2's to cancel. Then in my calculator, I would type in 2 tan 54. Again, I'm doing this so I can find the height of my triangle, so I can find the area of this triangle to then help me find the area of this regular pentagon. So when I type that into my calculator, giving you a little bit of time here, I should get back 2.75 inches. Okay, so now I have 2.75 inches. That is what this x value equals, 2.75 inches. Now that I know the height and I know the base, I can find the area of this one triangle. So the area of this triangle is going to equal 2.75 times 2, so base and height, divided by 2. Okay, now this is going to equal 2.75 inches squared. And again, this answer right here in the box is the area of one triangle. This triangle right here, I'm trying to outline it here. That's this one triangle. But remember, these numbers I labeled in here, this triangle happens 9 other times in this pentagon. So instead of just finding the area of the pentagon, I'm going to find the area of just a triangle because we've gotten really good at finding the area of a triangle. And I'm going to plug it in and I'm going to multiply this by 10 because there are 10 total triangles. So if I take 2.75 and I multiply it by 10 to cover all of my triangles, the area of the pentagon, put the triangle in there, the area of the pentagon then is going to be 27.5 inches squared. Okay, again, finding the area of the triangle so I can use that to help me find the angle of the pentagon. This might be a little bit confusing, but folks, I want you to make sure that you are jotting down any questions you might have. There's a lot of writing on this one slide. Make questions by certain things so that way when we get to class and we talk about this, you know exactly where you are confused. All right, so example number 2. Find the area of a hexagon with a radius of 9 inches. So again, we're going to want to compose that triangle. And this time we have a radius of 9 inches. So again, remembering that the radius is the distance from the center to a vertex. So my radius is going to be 9. Now here we're going to go to finding the interior degrees. So I'm going to go to n minus 2 times 180 because I want to figure out what this bottom angle is so I can find my height. Okay, so n is going to be 6 this time. 6 minus 2 is 4. 4 times 180 is 720 degrees. So I have 720 degrees. And if I notice here, I have 1, 2, 3, 4, 5, 6 sides. So that means I'm going to divide by 6 times 2 because every side makes up 2 different triangles. So I'm going to divide 720 by 12. And if I type into my calculator 720 divided by 12, we get back the angle measurement of 60. So this unknown angle here I now know is 60. Now this helps me because now I have a right triangle with an angle on one side. So I can use my rules for a 30, 60, 90 because I know I have a 60. So I can use the rules for a 30, 60, 90 to help me find the rest. So it looks like my hypotenuse is 9. In order to find my short leg, I take the hypotenuse divided by 2. So 9 divided by 2 would be 4.5. Okay, now I have to take 4.5 and I have to multiply by the square root of 3. I don't want to be dealing with the square root of 3, so I'm going to take that and I'm going to type that into my calculator. So I'm going to type into my calculator 4.5 times the square root of 3. And the answer we should get back then would be 7.79. Let's round 2 decimal places when necessary. So then the height here is going to be 7.79. Okay, now in this triangle, it looks like I do have my height and I have my base. So once I have my height of my triangle and my base, I can take the base, which is 4.5. I can multiply it by the height, which is 7.79. And then I can divide that by 2. Okay, so when you type that into your calculator, whatever answer pops up in your calculator, I need to multiply by however many triangles I have. Again, if I were to compose these triangles, I could write them all up, but it looks like I have 1 triangle, 2 triangles per one side. So when I have 6 total sides, that means I'm going to take the sides and multiply them by 2. I'm doubling my triangles for every side. So that means I'm going to have 12. So what I'm going to do with this number is I'm going to put it in parentheses, and I'm going to put multiplied by 12 on the outside. So the first thing I'm going to type in my calculator would be 4.5 times 7.9. I'm going to say hit equals. Then I'm going to divide that number by 2. Once I divide that number by 2, I'm going to hit equals again. And then I'm going to hit multiplied by 12. And once I type that all into my calculator, so I don't have to write out a bunch of different decimals and simplify every time or round every time, I'm going to type it all into my calculator at one time. Once you do that, the area of this hexagon is 210.33 units. Okay, but let's think back. What were my units? I have inches, so inches. And since I'm talking about area, that means I need to square it. So 210.33 inches squared would be the area of this hexagon. Again, this is not an easy concept to understand. It is getting more complicated. So if you have any questions, make sure you jot those down. I cannot stress that enough. So I want to thank you for taking good notes, and I'll see you in class.